So hello everyone. In the last session, we have seen the numericals on the Coulomb's law, and we have seen the different concepts. We have seen how to apply the Coulomb's law with the different concepts. We have also seen that how this Coulomb's law is mixed with the class 11th and different types of questions we have that can be asked. Now in the today's class, we will going to start a new thing, that is a new concept basically, and that is electric field we are going to start. Okay, and this is the last question which we have discussed in the class, as you can see, and we have calculated the value. I hope everyone has practiced this question because I told you to practice it again and to do it again. Now in this class we are going to start a new topic that is called as the electric field. We have till now we have seen about the Coulomb's law and we have discussed about the electrostatic force. So let us start. Okay, before going to that, we should have an idea of something called as a force in a medium. If we put a charge in a medium, because here we have treated as vacuum. If in the starting of the lecture I told you that we will discuss about epsilon naught. Epsilon naught is something which is depend upon the medium. In the property of like electrostatic force, I have written a one property, that is it is a depend upon the medium. Okay, so let us consider, suppose I have a charge let's give a topic, that is the electrostatic force in a medium. Okay, electrostatic force in a medium. Yeah, so what is this basically? Suppose I have a one charge. Okay, suppose I have a one charge. Okay, suppose I have a one charge q. Suppose this is my charge q is there and it is a positive charge. I place it into a water, so what will going to be happen? Or let us not water, some particle I have placed, some medium I put it this charge particle. Okay, and if you know a water H2O, water is what? Water is basically this, like this, H, and here we have a partial negative charge and there we have a partial positive charge. So it is a type of dipole. Okay, there is a negative ion and this positive ion, Okay, if you remember, this angle is even 106.7 degrees, something like that. Okay, so when I put this charge particle inside the water, what is going to be happen? The negative charge, what is going to be happen? There is a formation of a negative charge, like a negative ions will going to surround this positive charge, correct? A negative ions is going to surround this positive charge, and suppose there is another charge q is also placed here. Okay, there is another charge q is also placed here. Okay, and suppose this is negative charge, this charge is negative. So what will happen in this case? In this case, the positive charge is going to surround this thing, correct? Correct, this will going to be happen. So when you place it into the water, so what we have noticed, when we have placed the charge particle in the medium, it can be any medium, here we are taking as a water. Okay, then the charge induced, okay, this is nothing but an induced charge. This charge is nothing but an induced charge. So if initially if you see, if you see When there is a suppose they are placed in vacuum, this is my q, this is my q, and the distance between them is r. In that case, what is the force you will write? Net force. What is the net force you will write? That is nothing, sir, k q1 q2 by r square. Simple formula. Where what is k? Sir, k we know k is 1 upon 4 pi epsilon naught into q1 q2 by r square. Correct? That is a value we know. Okay, this is in air, in vacuum, that we know, it is in vacuum. Correct? This is in vacuum. Okay, now the next thing is that our question is that now suppose we place it into a water, that is this condition, then in that case what is the net force going to be on this? Suppose between this, what is the net force on this between these two particles? Or you can say simply, I want to find the force on this thing. So if you see this negative charge has a force due to this charge also and due to this negative sheet also. Correct or not? This negative charge has a force due to this positive charge as well as this negative sheet which is formed. Correct? So here my net force will be remain same or it is change? It will be change. Obviously here the net force will be change. So if I tell you what will be the net force direction, see, this positive charge will try to attract this negative charge. Correct or not? This is F1. This negative sheet will try to attract this this positive charge try to attract this negative charge, and this negative sheet which is formed due to the induction, this will try to repel it with force F2. So what is my F net? My F net, I can say it will be nothing but it will be some F1 minus F2. I don't know whether which one is greater, which one is smaller. Okay, I don't know. I am just writing this will be F1 minus F2. Now what is F1? What is F1? Tell me, what is F1? Sir, F1 is a force between these two charged particles when they are in air. Because we have read one property, that is force is the electrostatic force is independent of the charge which is present, another charge which is present. That is means the force between the two charged particle is independent of the another charge. Correct? So I can say my F1 is nothing but, sir, it is k q1 q2 by r square. Correct? That is the same thing. It is not changed. That is the same thing. Minus this is F2, F net. Now I am going to write a value of F net. Okay, F net is it has been calculated and there is no derivation for it in our syllabus. So what is F net they have given? They have given F net is 1 by 4 pi epsilon naught into epsilon r. Okay, into q1 q2 by r square, that is equal to this force k q1 q2 by r square minus F2. And what is this F2? What is this F2? 1 minute. What is this F2? My question is, what is this F2? What is this F2? Can anyone tell me? What is this F2? Yes, sir, this F2 is nothing. This F2 is nothing but a force due to induced charge. Force due to induced charge. So from here you can say my epsilon naught into epsilon r is equal to some epsilon. Okay, so from here we get my epsilon r is equal to epsilon upon epsilon naught, where epsilon naught is the epsilon of medium, and that is for free space. I told you in the earlier class also. So this is called as a relative permittivity. This is called as a relative permittivity. So what is epsilon r? It is a relative permittivity. And this is the epsilon of medium, and this is epsilon. And now you tell me, epsilon of medium will be always greater than epsilon naught of free space. So epsilon r is always greater than 1, correct? So if it is like that, if epsilon r is always greater than 1, then in that case can I say my net force is reduced na? My net force, here the force is maximum and here the force is minimum. So from here what is the conclusion we have got? That whenever we placed any charged particle within the medium, then in that case the net force is reduces. My net force is going to reduce, that is the conclusion. And second thing, whenever you are solving a question, always read the question properly, whether they are asking the net force in a medium or whether they are asking the force due to the induced charge particle. Okay, whatever the charge are induced, whether they are asking about F2 or F1 or net F, that is what we have to see properly. Okay, so what is the conclusion we have got? The conclusion I am writing here, that whenever we place any charge particle in a medium, my net force is going to reduce. So conclusion is that our F net is always less than F in air. That is our conclusion. Clear? That is a very small topic, but the picture should be clear in your mind. What is the picture? Sir, whenever we are going to place any two charge particle inside the medium, the net force is going to be reduced. Why? Because of this parameter epsilon r, because the epsilon of that medium is going to be changed. So which has a maximum epsilon r or which has a minimum epsilon r? So medium will have a greater epsilon r than the air, and air will have a minimum epsilon r, so the force will be maximum. That's why force in vacuum is maximum force. This is F max between the two charge particles. This is my maximum force, correct? And when we are going to place into the medium, then my net force is going to reduce. I remember this my F2 is nothing but a force due to the induced charge particle on the another charge Q. Clear? Any doubt till here? Okay, so I can proceed further. Okay, so this is a small picture. Now you can solve as many questions as you want, but yeah, it's a simple thing. Now we are going to move our very important topic, that is electric field. Okay, that is electric field. What is electric field? Okay, see, this is a defined thing. It is defined by us, defined by scientists, defined by them. You can't see it, you can't feel it. Okay, you can't feel it. That is the thing. That is why class 12th is more difficult, because we can't feel it. So let us define the thing, that is electric field. Okay, electric field. Okay, electric field. Okay, so let's see what is electric field. See, electric field has been defined. Suppose there is some charge is there. Okay, what they have did, suppose there is some charge, this is Q0, this is called as a test charge. Okay, this is the test charge. What is the test charge means? Test charge means its value is very small. Its value is very small. That means it cannot produce its own field. It cannot produce its own field. That is the one point you have to remember. What is that point? What you will understand it later when I explain you what is the electric field means. Okay, then you will understand it more in a more better way. What do you mean by that thing? Clear? Okay, now let us see what they have observed. When they there is some reason is there. Okay, they have seen what they mentioned there in their research. If you will see, they have mentioned that suppose they have found that in some reason, okay, suppose this is my reason, they found that when they have placed this test charge inside this region, they found that the test charges start moving in this direction. It move in this direction. Clear? It start moving in this direction with a velocity v, and there is nothing is there. Suppose it is a frictionless, nothing, no gravity, nothing is there, no force is there. What they have observed, that they have placed one charge particle Q0, and they have seen that this it moving with a velocity v. Okay, clear? Or then like they are thinking that why it is happening, then what they have basically done, that they have a place of one charge capital Q there. Basically what they have did, just try to understand, let me make it more clear for you. What is the basic thing they have did? Like they have placed a one charge Q naught in some region, and they have find that whenever they place a charge Q naught in that region, they are finding that this charge is moving with a velocity v. And when they placed in this region, they found that it is at rest. It is at rest. There is no motion. It is at rest in this region. So what they have concluded from here, and one more thing, that the first question is arising in their mind, that why this charge is moving when it is placed in this region. That is a question. So basically what is happening there, in somewhere here, they have placed a one capital charge Q, but it is not in, like it is not visible to this charge Q naught. Means Q naught doesn't know that there is a capital charge Q is placed there. Okay, and what they observe, that whenever the Q naught is inside some particular region, he is getting some force, and he is or she is experiencing some force, and due to which he is moving or she is moving. But there is no one is there who is applying a force on it. Means physically there is no interaction, but still it is moving. That means there is some quantity must be there that is applying a force on this charge Q naught. And what is that quantity? So that quantity is nothing but a electric field. So electric field is what? Electric field is defined as imaginary lines which cause the electric force. Okay, which basically help, or you can say which is the reason, that is a cause for a force of attraction or repulsion between the two charged particles. If there is no electric field, then there is no force, electric force will be there. Okay, so basically electric field, how they have defined mathematically the electric field, that is a definition. Okay, but how the mathematically they have defined, if you talk about mathematically, in mathematical point of view, they have defined electric field as, suppose there is a charge, they have defined electric field, that is E vector is equal to force on that charge particle, whatever the force acting on this charge particle, divide by its charge Q naught. Clear? Means force between these two charge particle divided by their test charge Q naught. That is my define as electric field. And what is a unit? Unit you can see from here. What is a unit? That is Newton per coulomb. And what is the direction? The direction will be same as that of force direction. Okay, the direction will be same as that of force direction. So from here I can write my F is equal to how much? F is equal to some Q into E vector. Correct? It is a vector quantity or a scalar quantity? Vector quantity. What is the magnitude? This is the magnitude. What is the direction? What is the direction? The direction is along the direction of force. Now if I ask you to calculate the electric field, then what you will do? What you will do? Do nothing. You just calculate the force and divide by the charge. Or it is better to say that if I write the definition, I will say what? I will make it very example, like very easy, because most of the student afraid from this, that how to calculate electric field. It's nothing. It's force only. It is defined as a force per unit charge. It is force. It's electric force. Okay. It is defined as force per unit charge. Unit charge. That means what you are going to do. Suppose I ask you one question. Let us better understand with the question. Okay. Suppose I ask you one question. What is that question? Suppose there is a charge Q is here and there is another charge Q is here. Okay. Q is here, and suppose the distance between them is R, and I want to find the electric field. What is the concept? The concept is very simple, or it is better to let me do one thing. Okay, suppose there is a charge capital Q is here. I want to find this distance, suppose R is there. I want to find the electric field at this point. I want to find E at this point. So what is the rule says? Bring the test where the rule is very simple. Whenever you have to calculate the field at any point, whenever you have to calculate the field at any point, at that point you place the 1 coulomb of charge. Place 1 coulomb charge there, and now calculate the force. F is equal to K Q into 1 coulomb divided by R square. Correct? This will become K Q by R square. That is my force. Correct? That is my force. Now what is the electric field? Force divided by per unit charge. Which charge? Test charge. This is my test charge because this only charge I have placed here, na. So K Q by K Q by R square divided by 1 coulomb. So I can say it is K Q by R square. Clear? So from here what we have got, the conclusion is very simple. Whenever any question they ask you to calculate the field at that point, what you have to simply do? You have to simply place the 1 coulomb charge at that point. And when you place the 1 coulomb charge at that point, then simply calculate the force, electrostatic force. That electrostatic force is nothing, it is what? It is a electric field. Simple, clear. Okay, so that is a conclusion, and this is also called as a electric field due to point charge. Electric field due to a point charge. So what you have to remember? You have to remember, if there is a charge Q is there and at some distance R, if I ask you what is my electric field, my electric field will be defined as K Q by R square. Correct? This is the, and the unit is Newton per coulomb. That is a thing you have to remember as a summary. That is a thing you have to remember as a summary. Clear? Clear? This is the thing you have to remember. And direction, you know how to find the direction will be same. Clear? Okay, that is a thing you have to remember. And how to calculate the electric field, that I told you the method. Whenever they ask you to calculate electric field at any point, what you have to do, you have to simply replace the you have to put the 1 coulomb of charge there and calculate the electrostatic force. That is going to be the electric field. So whatever the questions we have to solve till now, what you have to do, you have to simply replace that charge, okay, by 1 coulomb, and then you calculate the what? Force. Simple. That is a simple force, that is going to be the electric field. That is a thing we can do, whatever the questions we have solved till now. Clear? Any doubt? If I ask you the vector form, can you write the vector form for me? Can you write the vector form for me? Vector form of electric sorry, just ignore this noise. Okay. So suppose okay, so suppose there is a charge Q is there, and suppose this distance is R. At this point I want to calculate the field. What is my E vector? So simply what you have to write, E vector is equal to KQ upon mod of R cube into R vector. Clear? Simple. And you have to put Q with, what is the rule? You have to put Q with sign. Simple. Clear? So that is a conclusion for this thing. Clear? Any doubt till now? So that is about the electric field. Now we will This is only the electric field. There is nothing more about the electric field. This is the thing you have to remember for the calculation point of view for solving any question. Now let us move to the next thing, that is the properties of the electric field lines. Properties of sorry So what are the property? First property. What is the first property? Says that the field lines, which field lines? Electric field lines originate from positive charge and go to infinity. So if you see, you have to remember some of the diagrams, if you can remember, that is good. Like suppose I have a positive charge plus q here. So what is the diagram of electric field lines? The electric field lines will be like this. This is my electric field lines. Clear? How many number of lines, whatever number of lines you want, you can draw. So you can see it is originating from the positive charge and it is going to infinity. So that is a for first rule. These are the properties. First property. Second property. Second property. What is the second property? The electric field lines come from infinity and go to and enter to the negative charge. Means what is this thing? What is this? Suppose I have a negative charge. Clear? So what is this property state? That is, it will come from the infinity. Means the rays will, electric field lines will come from the infinity and it will enter inside the negative charge. That is a direction. That is the electric field lines for a negative charge. Okay. This is the electric field lines for the negative charge particle. Clear? I can draw something like this. Okay. Like this. So from infinity, so for positive charge particle, the field lines originate from positive charge and go to infinity, and for negative charge particle, the field lines come from infinity and enter inside the negative charge. Clear? That is the first two property. Second property, sorry, third property, na? It's third property, I think so. Yeah. Third property. What is the third property? If there is an electric field line, the tangent to the electric field lines, denote the E net at that point. Means what is this rule state? This rule states that suppose we have a Okay, I have to draw limit. Okay, suppose we have a curve. This is my electric field line. Suppose this is a electric field line, electric field line. Okay, suppose this is my electric field line. So what is I am trying to say that, suppose I want to find the field at this point. So what I have to do, at that point I have to draw the tangent. Okay, at that point I have to draw the tangent. So tangent at this point, this is the tangent at this point. And what does it mean? It means that the net electric field will be in this direction. Means the net electric field, this is my E net, and it will be in this direction at this point. Similarly, suppose I want to find at this point. So what I have to do? What I have to do? I have to put the tangent at this point. So at this point, if you will see, my net electric field will be at this point, my net electric field will be in this direction. Correct? Correct or not? So this is the third property. So at any point, if you want to find the net electric field on an electric field curve, you have to simply draw the tangent at that point. Clear? Any doubt? Any doubt is there? Okay. Now the next property. What is the next property? The electric field lines. The electric field lines never intersect each other. Just ignore the noise, okay? Never intersect each other. Why? Why it is not possible, sir? Why electric field lines never intersect each other? What is the reason? There is a reason. See, suppose there is a one electric field lines in this direction. One it is in this direction, suppose one in this direction, correct? So suppose they have intersected at this 2 point. Okay, you can see they are intersected at these 2 points. So at this point, if I draw the tangent on this curve, it will be in this direction, correct? At this point, if I draw the tangent in this direction, then there will be this point. It will be like this. So you can see at a one point, the electric field has a two directions, correct or not? Here, this is my E1 and this is my E2. So at a single point, how the two direction can be possible? Is it possible at a one point you have a two directions? It is not possible. So that means at 2 point, at 1 point, sorry. At 1 point, we can't have two directions of electric field lines. Okay, because at one point we can't have a two directions of electric field lines, so this is not possible. Means two electric field lines can never intersect each other. Clear? These properties are very important because JEE Advanced, JEE Mains, NEET, always they ask the questions on this property only. Clear? Second thing, the electric field lines never form a closed loop. Never form a closed loop. Why? Because it is a conservative force. Clear? Because it is a conservative force. Clear? Because it is a conservative force. Okay, so if it is a conservative force, the net work done in a closed loop will be 0. The total work done in a closed loop will be 0 because it is a conservative force, na. And if but if you calculate then in that case you won't get net 0. That means the electric field lines can never form a closed loop. Clear? That is a rule you have to remember, or that is a property, one of the property of electric field. Now next property, electric field lines are the density of electric field lines are directly proportional to the magnitude of charge. Like what I am trying to say is, suppose there is a charge q is there and there is a charge 2q is there. So what I am trying to say is that the suppose the field lines from here is, so how many field lines? 1 2 3 4 5 6 7 field lines. So from here how many field lines you will get? 7 from here. So you will get from 1 minute, sorry. Yeah. Yeah. So what I am saying, try to say that is this charge is more, na? So you will get more number of field lines from here. Means the density will be more. The number of field lines will be more. Because it has a more magnitude of charge. The charge magnitude is more, na? So you will get more number of field lines. Correct. And it is symmetric. I am not able to draw here, but it is symmetric. Okay. So that is a second property. Clear? Okay. That is a fourth property. Any doubt till now here? Anyone have a doubt till now here? If you have a doubt, please tell me. Okay. So shall I proceed further? Okay. Now the next property. Property number 6, not 5th, na? Yeah. Property number 6. Clear? Okay. Next property number 7. What is the next property state? Suppose I have a field line like this. This is called as a non-uniform electric field lines. Uniform electric field lines. Non-uniform electric field lines look like this. So suppose here we have electric field EA and here we have electric field BA. So from here, if I ask you, one simple thing, EA is greater than EB, EA is less than EB. Which one is correct? EA is greater than AB or EA is less than AB? How many of you saying EA is greater than AB? Okay. How many of you saying EA is less than AB? The correct option is EA is greater than AB. Why? Because here the density is more. So that means the electric field is more stronger. So more density, more stronger electric field. So that means EA is greater than EB. Clear? So here that means I can say density is directly proportional to electric field strength. Clear? More is the density, more will be the electric field strength. Any doubt? Clear? Okay. Next, move to the last but not the least, one very important property. See, I told you here a one property, if you remember, that is electric field lines never form a closed loop. But this property will get like there will be exception to this property is also there. We will discuss in the electromagnetic induction, that is induced electric field. Here just you remember electric field can never form a closed loop, but there will be something will come where electric field also will going to form a closed loop. Okay, that is the induced electric field. We will discuss that also. Clear? Till now anyone have a doubt? Okay, so let's move to the next property. What is the next property? State that, okay, we have covered this. Okay, next property is nothing but some diagrams of electric field. If you remember, that is better. If you don't remember, that is also better. Okay, so suppose my E is constant. Constant means what? Uniform. Everywhere it is same. That is the meaning. So it is represented by how you represent this. It is represented by a straight line. That is E is equal to constant. That is represented by a parallel lines of equidistance. Okay, this will be equidistance. It don't look like a equidistance, but yeah, this will be equidistance. Clear? That is you can say it is a seventh property. Okay, now some diagrams may like one most important diagram. Suppose there is a very famous diagram, it is given in NCERT also, plus q minus q. So what is a field line for this? So it is better you remember this field lines. Okay, because from positive charge the field lines go to the infinity, but there is a negative charge, so field lines enter inside it. Clear? Similarly here, clear? This is the field line for this. Clear? Now suppose one more case we can draw. Suppose this is my plus q and this is also plus q, and in that case what will my field lines? Okay, what will my field lines? My field line will be like this. My field line will be like this. Yeah, my drawing is not so much good. Okay, it will be something like this. Don't judge it, my drawing is very bad. Okay, so field line will go to infinity from the positive charge particle. Will it enter inside this charge? No. Why? Because it is a positive, na? So field line cannot enter inside the positive charge. So this will be go like this. Actually my drawing is a problem. If some noise is coming to you, please ignore it. Okay, so this is the field line for two positive charge particle. Clear? Any doubt? Just draw it. Done? Okay, let's take one example. That is a previous year question only. I think 3 similar charges are placed on equilateral triangle. equilateral triangle, then which of the following electric field lines are correct? You have to choose which of the electric field lines are correct. They have given the diagram. There are a lot of questions come on this. If you remember these properties, you can easily solve these questions. Okay, just you have to simply remember the property. The first they have given this option. Read the question very properly. Second, they have given this option. I think so. Maybe some option will be missed because I don't remember the question as it is. Okay. Third, they are not intersecting each other. Okay, remember, it look like they are intersecting. Let me draw it properly. Yeah. And fourth option, none of above. So which will be correct? If you see, you can directly answer. It will not take time. Till you solve this, I will write one more question. That is a logically very good question. Okay. I am writing another question. Till that, you tell me what is the answer for this. Q1, Q2. Solve it. I will check. Okay. Here. So these are the question. Just solve it and tell me what is the correct answer for this. See, if you see, it's very easy only. What is the property of electric field lines? The property of electric field lines that they do not form any closed loop. Now what they are saying, they have placed three similar charges, means the charges are same. Either you take plus q plus q plus q, or either you take minus q minus q minus q, doesn't matter. Place on the equilateral triangle, which of the following are the electric field lines are correct? See, here if you see, from positive, if I am treating as positive, so from positive to positive, the electric field line cannot enter inside the same similar charges. Either they will go to infinity or either they will come from infinity. So that is wrong. Second, closed loop will be not formed, wrong. Here, this can be possible because they are not intersecting each other. Also, they are look like they are coming from somewhere, but they are not intersecting. So this can be a possibility. None of this. So what is the most probable? Third option. Here what do you see? From here what you can comment whether they are of similar type or the different type, means the nature is similar or different. So nature is different. Why? Because one is emitting and another one is taking that electric field line. So I can say from here my Q1 is positive because electric field lines are emerging from Q1. Oh sorry, I draw the arrow in wrong direction. Na? Okay. 1 minute. Okay, this is correct. Yeah. So Q1 is positive and I can say Q2 is negative. Now you can see here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Only 6 lines are there. Here we have 7 lines. So from here we can say my Q2 will be greater than Q1. So Q2 magnitude will be greater than Q1. So second option will be correct. Now if they are of different nature and my Q2 magnitude is greater than Q1, where the net field will be 0. Now if you remember the equilibrium of charge, there we have learned the net field will be 0, only the left side of the smaller charge particle. So what is the smaller charge? Q1. So it will be 0 on the left of Q1. So my second option is third. So there it is a multiple correct. So the correct option is 2 and 3. This one is easy only. Major question is this question only. That is, so you have to remember, revise your all the previous concepts. Okay, you have not that if you are doing revision, then only you can understand the things. Clear? So till now we have covered what we have see all the properties of electric field lines, and we have covered the basic idea about the electric field. Now in the next class we are going to discuss about the constant electric field, and then we are going to move to the calculation of electric field by the different types of configurations, like infinite long wire, by a finite long wire, then we by a disc, by a ring, and the different cases we are going to cover, and then we are going to move toward the electrostatic potential and the dipole and everything that we will see after that. And this is how our first part of electrostatic 1 will be finished, because I used to teach electrostatic in 2 parts, electrostatic 1 and electrostatic 2. So our first part of electrostatic, that is going to be finished. Then we are going to start our next part, that is electrostatics 2, where we will discuss about the Gauss law and everything. Clear? Till anyone have a doubt here? If you have a doubt, please discuss, otherwise we are going to end this class. Okay, so in today's class we have seen a lot of things, and we have seen new concepts also. If we see, we have seen about the electric field lines, then we have seen the how to do the calculation electric field due to a point charge, then the vector form, and then we have learned one concept, that how to calculate the electric field if anyone asks you. Then we have seen the properties of electric field lines. These are the different properties. Please go through all the properties, and this is the example we have seen. Clear? So till now, take care, goodbye, and please like it, subscribe it, okay, and have a nice day, and do your preparation properly.